right? And I say our model because, as you know, if I had my way, you would have only heard about the net present value as far as Chapter 10 goes. But because some people actually do use, with some regularity, the internal rate of return. I'm happy to say that over time, the net present value has become as popular or more popular than the internal rate of return. But for the longest time, we had a bunch of old CFOs who were stuck on this internal rate of return because it was so easy to explain to their board members and other people. But we're getting away from that now. As more and more people get more and more MBAs and ultimately work their way up to CFO positions, they've taken the net present value with them, thankfully, because it is clearly superior to any other show in town. You will not see anything on this exam about payback unless it's why is payback hideous. Okay, so make sure you can handle that question. I mean, it's got all kinds of problems, but so does the internal rate of return, right? The internal rate of return will, under certain circumstances, flat lie to you. It'll tell you to take a project you should not take in lieu of another one that you should take, and that's no good. Because our goal is to maximize shareholder wealth, not just increase it. So taking an unacceptable or a second best project, even if it has a positive net present value, which it probably will, is certainly not going to maximize shareholder wealth, right? I mean, it'll increase it, but it won't maximize it. So if you just can teach everybody at every turn to use the net present value, you will have done a world of good out there financially. What else in 9?
Should we expect to have to calculate the internal rate of return?
No, you can, if I did not make that clear, there are 2 things I will not ask you to calculate because it's a trial and error process. The internal rate of return is one. What's the other one? Again, mathematically analogous, which came up in Chapter 12. Well, part of the weighted average cost of capital. Which one? We had 3 yields in there, right? Which one am I not going to ask you to calculate? Yield to maturity on a bond, right? That's the same problem. If you look at the internal rate of return, we're taking the present value of a series of cash flows. But it's only one rate, right? It's the first year, second year, third year, fourth year, fifth year. So all of these rates on the bottom of that fraction, all the discount rates, are separated by plus signs, but they're all the same rate. Well, the only way to find that answer is trial and error. Again, if you have a calculator that will do it, and you know how to make the calculator do it, I don't. I use Excel. You will see when you punch those keys in and say compute, there will literally be a pause of a second or 2. And you can actually sense it on your calculator. And all your calculator is doing is iterating over and over and over and over and over again different Ks, or since we're solving for it, we have a tendency to call it the internal rate of return, but they're looking for different discount rates until it finds that one that equates the present value of that project, or the net present value to 0. And I'm not going to ask you to do that. And again, yield to maturity is the same thing. If you've got a 20-year bond, you've got the same yield to maturity separated by plus signs. And now you've got to solve it again simultaneously. Your calculator has fun with that too. You can see a palpable time period between the time you say, give me that yield to maturity, and when you actually get it. So you will not have to solve for that. The others, you know, KE, KE primed, KP, absolute fair game. But again, you already work with those equations. This is just, I mean, even if you forget the manipulated equation, manipulate it yourself. I mean, you can do that. Okay, we're really talking algebra you learned many, many, many moons ago, which hopefully has come back a little bit since the beginning of September. What else in, where the hell are we? 9?
10.
10, thank you. Make sure you have a good handle on that chart we looked at, one of the last things we did. Net present value profiles. There is a tremendous amount of information on this. You know, where we talk about, you know, we got the 2 projects, L and S probably. One of them starts out bigger than the other, but ends up, you know, with hitting the horizontal axis, i.e. having a lower internal rate of return than the other. Make sure you understand if you understand what's going on that chart, you have a very good handle on you know, the net present values and internal rates of return projects. And it's in your textbook as well. Yeah, remember we use that to look at when I, you know, remember projects give us the internal rate of return, the net present value have the potential to give us different answers if we have projects that have different scale, different cash flow timing, and are mutually exclusive. And if you remember, we looked at that chart and looked at what would happen for independent projects, and we had never had a conflict. But the minute we allowed the projects to be mutually exclusive, all of a sudden, when those three conditions were met and we had a weighted average cost of capital below the crossover point, where those two net present value profiles cross, then we ran into the situation where the net present value would tell me to take one project, the internal rate of return another. And again, sadly, the conditions that would cause the internal rate of return and net present value to give us different answers exist a significant amount of the time. Okay, so this is not some idle thing that we like to play with theoretically in finance. This is something where organizations who don't use the net present value under the circumstances that exist today with rates where they are could day after day after day be making suboptimal decisions. Not a good thing. What else in 10? What about 12? I got an